So I'm going to be working through the second implicit differentiation worksheet in this video. I think I'll talk through the first 2 or 3 answers, and then I'll turn off the video and do the rest, and then turn it back on and show you. That way the video doesn't get too long. Okay, so implicit differentiation. The idea is that I don't want to sort out the x's and y's. I could in this one, obviously, but I don't really want to do that. So what I do is just take the derivative of both sides. Keep in mind that I'm taking the derivative with respect to x. So when I take the derivative of this side, for example, so really what I'm doing is taking dy or d something dx of both sides. So that's what I'm doing. Taking the derivative of the 2 sides with respect to x. So the derivative of the left side is going to be 2 times 3x plus 7 times the derivative of 3x plus 7, which is just times 3. The derivative of the right side is going to be the derivative of 2y cubed, which would be 6y squared, times the derivative of y, which is, of course, dy dx, because I don't know what it is. I don't know how y changes with respect to x. So over on this side, I got a 6 times 3x, which would be 18x, and a 6 times 7, which would be 42. And over here, I have a 6y squared dy dx. So I divide both sides by 6y squared. I get 18x plus 42 divided by 6y squared. And that is dy dx. And that would be my answer, because there's nothing else to simplify there. So I go to the second one here. I think before I do this, because I don't like the, well, no, I'll just do the question rule. Okay. So once again, I take the derivative of both sides of this. So the derivative of the left side with respect to x, that's going to be just 2x. The derivative of the right side is going to involve the chain rule. So that would be low d high. Now the derivative of the high would be 1 minus dy dx. Minus, let's see, low d high, high d low, which would be 1 plus dy dx. And then the bottom of that thing is going to be x plus y squared. So now we've got to get dy dx by itself. So the first thing I'm going to do is multiply both sides by x plus y squared. So that would give me 2x times x plus y squared. And then over here, I'm going to have to multiply these things out. So actually, do I? Nope. Yeah, I do. So that would be 1 times x is x, 1 times y is y, dy dx times x, that'd be a negative x dy dx. And dy dx times y, that'd be a negative y dy dx. And if we keep going to that, over here, we're going to have 1 times x is, and that's got a negative out front, so that's going to be a negative x. And 1 times negative y, but that's a negative negative y, so that would be positive y. And dy dx times that. So then dy dx times negative x would be a negative x dy dx. And then dy dx times a positive y, that'd be a positive y dy dx. It's a positive y because it's a negative negative y. Okay, let's see, what can we do? So we want to get rid of all the stuff that's not dy dx in it. So that would be on this side, we're going to have 2x times x plus y squared minus x because of that guy, minus y because of that guy. And then these guys will stay there. And then a plus x. Oh, wait a minute. Let's back up a second. So that negative x and that positive x will cancel out. So really all we have is these 2 y's, don't we? So the only thing that show up over here is a negative 2y. There we go. The rest of the stuff has x's, or has dy's, dx's in it. And actually notice that this negative y dy dx and that positive y dy dx, they cancel each other out, don't they? So really all I have on this side is a negative 2x dy dx. So my final answer is going to be down here, dy dx is equal to 2x times x plus y squared minus 2y all over negative 2x. That was a humdinger. Okay, I'm going to do a couple of these down to maybe 6 or maybe 8. And off video, and then I'll turn the video back on. Okay, so there's number 3. Magically, they're all done. Number 3, just took the derivative of both sides. Had to use a quotient rule on this side over here. And on the right side, there was nothing but x's, so it was just like a normal derivative. And then notice the top ended up being just 2. When I divided both sides by 2y, the 2's canceled, so I got that. Over here, notice the key here is in that middle term. That's a product rule, so you got to take the derivative of the first, which is 1 times y, and the derivative of the second is x times the derivative of y, which is dy dx. Notice also that negative distributes, so both of those terms are negative. And then you just separate out the stuff that's not dy dx and then divide all the stuff over. Here's 5. This is a little bit tricky because the y is inside the tangent. So it's a chain rule. I take the derivative of the tangent first and get secant squared y. And then that's times the derivative of y, which of course is dy dx. Then I just divide by secant squared, and then I did a fancy little trig rule there. 1 over secant is the same thing as cosine, right? So same thing here. There's a y inside the trig, so I had to take the derivative of the sine. And then we get the dy dx is on one side, everything else on the other side, and then divide them out. Okay? These are a little bit more complicated, so I was going to do these on the video, talk you through them. So this first, the left side has a product rule with chain rules in it, of course. So the derivative of the first would be 2y dy dx times cosine of 1 over y plus y squared times the derivative of cosine, which would be negative sine of 1 over y times the derivative of 1 over y, which of course would be negative 1, or negative y to the negative 2, and then times the derivative of y, which would be dy dx. So that's a little bit tricky. Then on the right side, I'm derivative of 2x, that's just 2. Derivative of 2y, that would be 2 dy dx. Now we got to get the stuff together, so let's see. The negative y squared is being multiplied there, so the negative y squared, negative y to the negative 2 times y squared, those are going to just cancel each other out, so that's kind of cool. So over here, I'm going to have a 2y cosine of 1 over y times dy dx. And over here, I'm going to have a minus sine of 1 over y dy dx. Then I'm going to move that other guy over there, plus 2 dy dx. And I'll just have a 2 over there. Factor out the dy dx's, and I get dy dx is equal to a 2 on top and all this other stuff on the bottom. Cosine of 1 over y minus sine of 1 over y plus 2. So the key here was noticing on this side you have a product rule. On the left side you have a product rule. Okay, so here's another one that's very interesting, kind of challenging. Take the derivative of the left side, that e to the xy, of course the derivative of that is just e to the xy times the derivative of xy, and that's going to require the product rule. So that would be 1 times y plus y times, x times the derivative of y, which would be dy dx. And then derivative of ln y would be 1 over y dy dx. And on the left side, we just have a 2. So we'll distribute that e to the xy through. So I have y e to the xy plus x e to the xy dy dx plus 1 over y dy dx equal to 2. So let's move the thing without the dy over. So then we're going to have x e to the xy dy dx plus 1 over y dy dx is equal to 2 minus y times e to the xy. And then finally, if we factor that stuff out, we're going to have dy dx is equal to 2 minus y to the e to the xy over x e to the xy plus y to the negative 1. I guess we could do that. But I'm not so comfortable with the negative exponent in the middle of the fraction. That's like a complex fraction. So what I'm going to do is multiply top and bottom by y. And that would give me dy dx equal to 2y minus y squared e to the xy all over xy e to the xy plus 1. Okay. Of course, when we multiply top and bottom by y, we have to distribute the y, right? So that's where we go y times 2 gives me that, and y times that gives me y squared. Y times this gives me the y in the middle there, and y times y to the negative 1, of course, is just 1. Okay, so number 9. Now it says tell whether the graph is concave up or down at the given point. So that, remember, concavity comes from the second derivative, so we're going to have to take a second derivative and then plug in the 1, 0. Okay, so the first derivative, I take derivative both sides, and I get 2x plus 2y dy dx equals 1. And since I'm just looking for the first derivative, well, actually, I'll do this the normal way first. Okay. Maybe I won't. So since I'm just looking for the first derivative here, I'm sorry, the second derivative, I could just go ahead and take the derivative again. Instead of having to solve for dy dx, I can just take the derivative right now. So the derivative of 2x, so if I take the derivative of both sides again, I get 2 plus, now I have to do a product rule here. So that would be 2 dy dx times dy dx plus 2y times the derivative of that, which would be d squared y dx squared. Remember, that's how we write the second derivative. And of course, the derivative of 1 is 0. So now, remember, our goal is to find out whether this thing is concave up or down at the point 1, 0. So really, all I need to do is plug in 1 for x and 0 for y, and then solve for the second derivative. Okay? So I've got a 2 plus 2 times dy dx squared plus, and I put a 0 in for y. Of course, that whole thing, oh shoot, we can't use this to tell whether it's concave up or down, can we? Yeah, I didn't think that one through very clearly. Yeah, so that means at that point we can't test for a concavity. Because notice when I plug in 0 for y, this whole term cancels out, and that's the only term that had the second derivative. Notice here, this is the first derivative times the first derivative, which is the first derivative squared. So that's not the second derivative. This is the second derivative. Now, if we were to finish this, what we would do is we'd plug in we'd have to find something for dy dx, so we'd have to go back up here and solve for dy dx. But notice when you plug in 0 for y, the dy dx is canceled again, so we couldn't even do that. So, okay, that was a bad example. Okay, how about this one? Take the derivative of both sides, I get 2y is equal to 2x. Oh, whoops. 2y dy dx. All right? That would be 2x plus 2. And again, I'm looking for the second derivative, so I'm just going to take a derivative again. And the product rule applied to the left side, so that would be the derivative of the first, which would be 2 times dy dx times dy dx plus 2y times the derivative of dy dx, which would be the second derivative. And the derivative of 2x, of course, is 2. The derivative of 2 is 0. Okay, so now, again, my goal is to find the second derivative. So I'm going to plug in 1 and rad 3, 1 for x and rad 3 for y. And I'm going to go ahead and find out what dy dx is right now. So if I plug in rad 3 for y, that would be 2 rad 3 dy dx. Plug in a 1 for x, and that would be 4 over here. So I know that dy dx evaluated at the point 1 comma rad 3 is equal to 4 over 2 rad 3. Okay, so then I'm going to go over here and say, okay, this is 2 times 4 over 2 rad 3 times 4 over 2 rad 3 plus 2 times 1, which would be 2, times the second derivative, which is the thing I'm looking for, equal to 2. Okay, so now we just got to solve for the second derivative. So over here, that's going to be this 2 and that 2 will cancel out, and this 4 and that 2 will cancel out, leaving a 2. And rad 3 times rad 3 is 3. So we end up with 8/3 plus 2 times the second derivative is equal to 2. So if I add 8/3 to both sides and divide by 2, so let's see, I guess I'll hold off on the dividing by 2. If I add 8/3 to both sides, that would be, 2 is the same thing as 6/3, so that would be 14/3, wouldn't it? And then I divide both sides by 2, and I get d squared y dx squared is equal to 7/3. Now, the question actually only asked is tell whether the graph is concave up or concave down. And remember, concave up, the second derivative would be positive, and concave down, the second derivative would be negative. So actually, early on here, we could have said it's concave up, because we know, you can tell very early that you're going to get a positive number down here, aren't you? Whoops, nope, we aren't. I messed up. Got it. Back up, back up. When I moved the 8/3 over, I didn't subtract it. So this should have been 2 times the second derivative. I'm glad I caught that. Is equal to 6/3 minus 8/3, wouldn't it? Yeah, so that would be negative 2/3. And then if I divide both sides by 2, I get the second derivative is equal to negative 1/3. So that means it's concave down, because my second derivative is negative. Okay. Moving on, find the equation of the lines that are tangent to the curve at the given points. So once again, tangent line is, we use this y minus y1 is equal to the slope times x minus x1. And the slope, of course, comes from the derivative. So we need to find dy dx and plug in 1 and negative 2 for it. So I'm just going to do the implicit differentiation. So I'm going to take the derivative of both sides of the equation. So this first one is going to be a product rule. That's going to be the derivative of x is 1 times y squared plus x times the derivative of 2y, of y squared. That'd be 2y dy dx. Plus the derivative of the second term, that's another product rule. So the derivative of the first would be 2x times y plus the derivative of the second, which would be x squared dy dx. And the derivative of 2, of course, is 0. That's fun. And so again, if I'm looking for dy dx, I don't have to solve for dy dx first and then plug in the numbers. I can plug in the numbers right now. So I'm going to plug in negative 2 there. So that would be negative 2 squared plus, plug in a 1 for x and a negative 2 for y. So that would be, I can do some of this in my head, right? Negative 2 squared, of course, would be 4. This is going to be 1 times 2 times negative 2, which would be negative 4 dy dx. And this is going to be 2 times 1 times negative 2, so that'd be negative 4. And that's just 1 squared, so that's just dy dx. Oh, look at that. So the 4 and the negative 4 are 0. Right? So then we have a negative 3 dy dx is equal to 0, which means dy dx is equal to 0. So that means that the slope is flat at that point. That's kind of cool. So what would the equation of the tangent line be? Well, that would just be y minus, y minus a negative 2, which would be y plus 2 equals 0, aka y equals negative 2. Horizontal line at that point. Okay, let's do this one. That one looks crazy tricky. So take the derivative of both sides. So to derivative of this first fraction, I think I'd rewrite this as x plus 1 to the negative 1 plus y plus 1 to the negative 1 equals 1. And then take the derivative of both sides. So the derivative of this would be negative 1 times x plus 1 to the negative 2 times 1 plus negative 1 times times y plus 1 to the negative 2 times dy dx, and that's equal to 0. So I think we want to switch these back to fractions before we do anything. Well, actually, I could move this to the other side. So I'm going to have negative 1 over y plus 1 squared dy dx is equal to 1 over x plus 1 squared. And then let's throw in some 1s for x and y. So I'm going to have a negative 1 over, what would that be? 2 squared, right? So that'd be 4 dy dx. Over here I'm going to have a 1/4. So if we multiply both sides by 4, actually by negative 4, we're going to get dy dx is equal to negative 1. So the slope at that point is negative 1. So then if we write the equation of the tangent line, that'd be y minus 1 is equal to negative 1 times x minus 1. This video is getting long. I'm going to pause it. So I did number 13 through 16 off the camera so we can get through this because the video is getting kind of long. So there's number 13. There's obviously a product rule on the left side there. Plug in the negative 1 and 3. There's number 14. Well, there's the answer to number 13 back there in case you're checking. And there is number 15 and number 16. And just in case you want to attempt the bonus is the idea of your kind of application to this implicit differentiation. The demand for a certain product is given by x cubed plus p cubed equals 1200, where x is the number of units sold and p is the price of the unit. Find the rate of change of price when x equals 5 units. So the rate of change of price, that would be based on the units, that would be dp dx, wouldn't it? So as you change the price based on the units. So if we take the derivative of both sides, we get 3x squared plus 3p squared dp dx equals 0. So then if I move 3x squared over, we would get 3p squared dp dx is equal to negative 3x squared. Divide both sides by 3p squared. Of course, the 3's will cancel out, and I get db dx is equal to negative x squared over p squared. So that's a formula. I want to know what happens when it's 5 units. So dp dx when x is, when x is 5. See, that would be what? Negative 5. Oh, negative 5 squared, so that'd be negative 25 over p squared. I don't know what p is, so I have to go back up here and find p. So if I put a 5 in for x, I would get 125 plus p cubed is equal to 1200. Subtract 125 from both sides, and I get p cubed is equal to 1075. So down here, I'm going to get 1075 cube root raised to the second power, so that'd be to the 2/3 power. So that would be my that would be the rate of change of price. Okay, and that is the end of the video.